We have now learned two reactions of alkyl halides with four different mechanisms. In this highlight video, we will devise a strategy where, for a given alkyl halide, under specific conditions, we can predict whether the reaction will proceed through an SN2, SN1, E2, or E1 mechanism. Let's start with some general considerations. Strong nucleophiles or strong bases are going to favor either SN2 or E2. These strong bases can be things like hydroxide, alkoxide, so these are the conjugate bases of alcohols, or another strong nucleophile that's a strong base is this acetylide. So this is the conjugate base to an alkyne. Weak nucleophiles or bases favor either SN1 or E1. And so weak nucleophiles and bases are things like water or alcohols, or maybe in some cases carboxylic acids. Good nucleophiles that are weak bases, and there's only a few of these, can favor substitution over elimination. Examples include thiolate anions, like this, or with an alkyl group here. Cyanide is a good nucleophile that's a weak base. And in fact, some of the halides like bromide or iodide, these are good nucleophiles but weak bases, and they can favor substitution over elimination. Bulky bases favor elimination over substitution. So kind of the prototype bulky base is this one here. This is called tert butoxide. And remember, whenever we have these anions, there's going to be some kind of cation, usually a potassium or a sodium that's associated with it, but those cations don't really participate in the reaction. Other common bulky bases we presented before, DBN and DBU. So you can just remember those. The structures are kind of complicated. They're not so important to remember. Let's overview how we will make decisions of what mechanism will be the likely one. The first thing we'll do is look at the alkyl halide. So primary, secondary, tertiary. For primary alkyl halides, we know that the mechanism has to be either SN2 or E2, right? Neither SN1 or E1 can take place for a primary alkyl halide because the carbocation would be too unstable. For secondary alkyl halides, this is the most challenging one. Any or all of these mechanisms can take place. For tertiary alkyl halides, the only one that can't take place is SN2. Tertiary alkyl halides are too sterically congested for an SN2, but we can have SN1, E1, or SN1. Let's look. So for primary, if we have a strong nucleophile, particularly if it's small, it's going to favor SN2. If we have a strong nucleophile and that's a strong base and it's bulky, so it's big, substitution is more difficult and we will see more elimination, E2. For secondary alkyl halides, if we have strong bases and or nucleophiles, we will get a mix of SN2 and E2. If we have a strong bulky base, we can push that predominantly to elimination, to E2. If we have a weak base or nucleophile, we usually get a mixture of SN1 and SN and E1. There's one set of conditions that we could add in here, and we already kind of talked about this, is if we have a good nucleophile that is a weak base, then we can get it to go SN2. Remember, these are things like thiolates, cyanide, and some of the halides. For tertiary, if we have a weak base or a weak nucleophile, we get a mixture of SN1 and E1. And if we have a strong base, whether it's small or big, we get E2 elimination. We cannot do SN2 for a tertiary alkyl halide. Let's look at some examples. All of these are primary alkyl halides. We know that they can do either SN2 or E2. So we look over here. We have a strong nucleophile that's reasonably small. This is going to go by SN2. So this methoxy group will replace the bromine. In the second one, we have a strong base, but it's bulky. Okay, this is tert butoxide. And so this is going to favor E2. None of these are usually exclusive, though. In both of these, we probably get some mix of substitution and elimination. The third one down, we're using a weak nucleophile, a weak base. So what's it going to do? Nothing. No reaction, right? Because these are conditions for SN1 and E1, but we just can't form a carbocation from a primary alkyl halide. The last one uses this acetylide, and this is a very strong nucleophile, strong base, and notice what else we see here is that we have an aprotic solvent. These all together favor SN2. And so we're going to displace that bromine with the triple bond, and we're going to get this product here. This is an important reaction because it's a way to make carbon-carbon bonds and to extend a carbon chain. Here are examples for secondary alkyl halides. Here we're using a strong, small nucleophile, strong base, and so this will tend to give us a mixture of SN2 and E2. Here's our substitution. So this is SN2 plus E2. And E2 would give us the alkene. The next one, we have a weak nucleophile or weak base, and so this can only go through SN1 plus E1, and when we do these, we always get a mixture. We'll just draw out what would be the most likely major products. And so if we do SN1, we have some stereochemistry there. Remember that substitution by SN1 gives us a mixture of products. So we're using water as the nucleophile, so we get an alcohol as a product. This would be for retention. Here is inversion. Right? We get a mixture of those two plus our elimination product will just show the one that follows Zaitsev rule. So we get a big mixture under these conditions. The last one, we see that we have a good nucleophile. Oops. It's a weak base. And so this can favor SN2. So this methyl group is unchanged, and we're doing SN2, so we get inversion of stereochemistry. So our product will have this thiol pointing up. Here are some examples of tertiary alkyl halides. Here we use a weak nucleophile, weak base, and so this gives us a mixture of SN1 plus E1. We have a tertiary alkyl halide, so that can readily form a carbocation intermediate. All right, there is no chiral center here, and so our substitution, even though it can go by either retention or inversion, will both give us the same product. So here's our SN1 product, plus we'll show the product from Zaitsev's elimination would be like this. So we get a big mix of this. The last one, tertiary alkyl chloride, we have a strong base, so this will go by E2. And again, it should follow Zaitsev rule, so this would be our major product. Continue looking at examples in the book and keep practicing so you can become comfortable making these predictions.